Hello everyone, you're welcome to today's video. I remain your tutor, Mr. Life Changer. Okay, so in this video I want to run through some questions on naming of compounds. I'm going to do a lot of explanations, a lot of manipulations for us to understand how naming of organic compounds works. Okay, so the first question here says, what is the IUPAC name of the following compound? Now, I want to note something here. Whenever you see an alkyl group in a bracket, you are going to make it a branch. Now, what I mean by alkyl group, we use R to represent them, and the formula is CnH2n plus 1. Okay, the first member of alkyl group is methyl, CH3. Okay, we call this methyl. Then it continues. We have CH3, CH2, which we actually call C2H5. Okay, C2H5, because if N is 2, this will be 2 times 2, 4 plus 1, 5. Okay, this is ethyl. Okay, then you have C3H7, which is CH3, CH2, CH2, and this is propyl. Now, these are not compound, they are simply attachment. That means they must be attached to something. Okay, so anytime you see them in a bracket like this, it means that they are a branch. And so if I want to rewrite this, I'm going to write it as CH3, then CH has a branch which is CH3, you see that? Then after that you have CH2, then you have CH2, then you have CH3. You see, that makes it easy. Now, in naming of compound, you are going to select the longest chain, and please note that the longest chain does not, it can be any shape, it can be zigzag, it doesn't have to be straight. So that means my longest chain here can be 1 2 3 4 5, or I can say 1 2 3 4 5 here. You know, it can be straight, it can be zigzag, it can be L shape, you know, whatever shape. But in this case, it may be convenient for me to pick the straight one, since it is all 5 5. Now, if after selecting the longest chain, you will notice some things attached to it, some members. Like the only substituent attached to this is this CH3, and the name of this substituent is called methyl. Okay, I want you to note that it's called methyl, and methyl is at position 2 of this carbon chain, so I'm going to call it 2-methyl. Now, what I mean by position 2 is that you can count from anywhere, but you must take the lowest position. If I count from here, it's going to be 1 2 3 4. Methyl is going to be in position 4. But if I count from here, 1 2, methyl is in position 2, so I'm going to take methyl. Can you see that? So that is why this is 2-methyl. Then the length of the chain, 1 2 3 4 5 carbon atoms, that is pentane. Okay, so pentane. So the answer to this question is 2-methyl pentane, as simple as that. Now, but I want to add something here, just a bit. Now, in a case where you have something like this, CH3C, CH2, CH3, then let's say you have H here, CH2, CH2, CH3. Now, I want you to notice that the bond of carbon, carbon chain always terminates with CH3. Can you see? CH3, 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 and the remaining is always CH2, CH2. The only time a carbon chain is not CH2 is when maybe it has an attachment, like this carbon now has this attachment. That's why it doesn't have 2 hydrogens. It has only 1 hydrogen. Another case is maybe it has multiple bond, maybe a double or a triple bond. So in a case like this, if I want to select the longest chain, it is going to be 1 2 3 4 5. No, I know some of you, that's what you think, but the answer is 1 2 3 4 5 6. That's 6. Even if I have something like this, let's say this is CH3, the longest chain is still going to be 1 2 3 4 5 6 7. That is 7. So if I want to name this, if I select the longest chain, this only substituent I have here is methyl. So, and methyl is in position, let's see, If I count here, it's 1, 2, 3, 4. If I count this way, 1, 2, 3, 4. Anywhere I count is still in position 4. So that's going to be 4-methyl. Then the longest chain is 7, which is heptane. Okay, so that is one thing you should note about naming of a compound. I'm going to be touching them as we continue. Now the next question says, name the branched alkane. Okay, so you can see that a methyl group, this has 2 branches, is an alkyl group in a bracket. So if I want to write this out, it's going to be like this: CH3C. This C has 2 branches, CH3, one here, another CH3, another here. Don't forget this. Then, and you have after that, you now have this CH2 here, and you have this CH3 here. So this is exactly what we have. This is how you open this organic compound, and that is very, very important. Okay, so if I want to select the longest chain, this is going to be 1, 2, 3, 4. You see, or 1, 2, 3, 4, or 1, 2, 3, 4. 4 is the longest chain. So let me take this for convenience sake, the horizontal one for the longest chain. 4 means that the parent name is butane. Okay, now for the substituent, if you notice, we have 2 substituents here and they are the same, so I'm going to call it dimethyl. You see, dimethyl. Then I have to put name for the substituent, I mean the number. I think counting from here is the easiest. So 1, 2, both of them are in position 2. So that's going to be 2,2 dimethyl butane. That's the answer to the question. So the answer is A. Now, but I want to note some things here. Some more things here is that we could have something like this: CH3, then CH, C2H5, CH, C2H5. Now, when you have something like this, what does this mean? Now, if you want to open this up, you should learn how to open up. This is going to be CH3 first, then we have CH. CH is not up to CH2, that means there is a branch. So, and the branch is C2H5. You don't write it as C2H5, or else you are going to make mistake. So C2H5 should be written as CH2, then CH3. You see that? Then after that, we now have CH. CH means that there is a branch, and the branch here is C2H5. So I can write that as CH2, CH3. Whenever you see C2H5 or C3H7, always increase it, always expand it. You know, CH2, CH2, CH3, CH2, 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 CH3, and all of that. So you can see that this has been, brought down to this. So my longest chain now is 1, 2, 3, 4, 5, 6, and that is 6. You see, 6 means it is hexane, and the only substituent is this methyl. So I'm going to write methyl hexane here. Then the number should be 1, 2, 3. That's the easiest, because here is 1, 2, 3, 4. So it's in position 3 if I count from here. So the answer is 3-methyl hexane. You have to put a dash. I hope that makes sense. And before I move on to the next one, I want to note something here, that whenever you see a CH2 in a bracket, it means to repeat. CH2, it means to repeat. For example, if you have something like this: CH3, CH2 in a bracket, let's say 3 times, then another CH3. Now what this means is CH3, then this CH2 will be repeated 3 times: CH2, 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 then before the last CH3. So please note, the only one that becomes a branch are any of the alkyl groups. So I have just explained to you how to name alkanes, right? And okay, so now for the next one here are alkenes. Now what makes alkenes different from alkanes is that in alkanes you can count from the left or from to the right in order to get the number of the substituent. But in the case of alkene, you can only count, it is the functional group that should take the lowest possible number. The functional group I mean here is the double bond. So if I want to write this now, this is going to be written as CH2, okay, double bond, C, then CH3, then we have CH2, CH3. Now don't forget that this is supposed to be CH3, but because of the double bond occupies all the space. Just know that the bond around carbon must be 4. That's how you know your structure is correct. So it can be only single bonds like this, or it can be a double bond and 2 other single bond, or it can be triple bond and 1 other single bond. It can be any of this, right? The bond around carbon must be 4. So if this carbon has 2 bonds here plus these 2 hydrogen making it 4, this carbon has 1, 2, 3, 4, 4. This carbon has 3 hydrogens plus this bond making it 4. This carbon has 2 hydrogens plus these 2 bonds around it making it 4. This carbon has 3 hydrogens plus this 1 bond making it 4. You see, quite easy. Okay, now the longest chain is still 1, 2, 3, 4, and please, the longest chain must contain the functional group. So that means this is my longest chain, 1, 2, 3, 4. Okay, and I'm going to start from here to name must 1, 2, 3, 4. I don't bother with the substituent. It must start from here. The reason is because the double bond starts from here at the position 1. So the functional group must take the lowest possible number. So in this case now, the parent name 1, 2, 3, 4 is boot. You are going to call that boot 1 in, because the double bond is in position 1. So you must write the position of the functional group. And CH3 is methyl, which is in position 2. The substituent is methyl and is in position 2. So this is 2-methyl but 1 in, which is A as the answer. I hope that makes sense. Okay, now I want to say something here. Okay, I think this second one helps me to blue trace it. I want to check something. Yeah, where is it? This one. Yes. Now we are asked to name this compound. So we have, if I should write this out, this is going to be CH3 CH3 as a branch, remember. Then you have a double bond CH, then you have CH3. Okay, so the longest chain is going to be this 1, 2, 3, 4, but this time around the double bond is in position 2, so that makes it but 2 in. Okay, and it is easier to this 1, 2. That means I must count this way, 1, 2. The functional group will determine the counting. Once there is a functional group, that is what will determine the counting, no longer the substituent. So following the counting of the functional group, the substituent is in position 2, so that will be 2-methyl. So the answer is 2-methyl but 2 in. Okay, now I want to make two explanations or 2 illustrations here. Now the first one is that you could have something like this. Let's say you have something like this, okay? And let's leave it this way. Now the longest chain here is of course 1, 2, 3, 4, 5, 6. Okay, that is hexane. But now the hexane, you must include the position of the double bond. So I can count 1, 2. This is the lowest, the carbon before the double bond. So 1, 2. So that means hex 2 in. You can see that if I count from here 1, 2, 3, 4, that's too big, so I must follow counting. That means the name of this compound now, remember, if I follow this, I have only one substituent here, which is methyl. So I'm going to have methyl here as a substituent, and methyl is in position 1, 2, 3, 4, 5. You see, 5-methyl. While it was alkane I was teaching, we would have counted 1, 2, 2-methyl, but no. Anytime there is a functional group, it is the functional group that now determines the numbering of the electrons. Please note that. Okay, I hope you understand that. Now the next thing I like to mention here, which is extremely very important, is that methyl is not the only substituent. We could have more than one substituent. There are many other substituents. There is chloro, okay, there is bromo, and all of that. So I wanted to write an example of chloro and bromo. So let's say you have let's say you have 1 2 3 4 5 6 7 8. Let me say I have a chlorine here, and this is CH3, CH2, CH3. This is CH2, CH3. Okay, and this is CH3, and this is CH. Okay, this already has 2 bonds, so this should be CH2. This one has 3 bonds, so this should be CH, and this one is CH3. Okay, so this is an alkane, but if you notice, different substituents. Now, like I mentioned, the first thing is look for the longest chain. I can count any. I can say 1 2 3 4 5. No, 1 2 3 4 5 6. I think that's the longest chain. There is no other corner, so I'm going to make this my longest chain. So 6 here represents hexane. 6 represents hexane. Okay, now for the substituents, we have different substituents here. The first substituent I can notice here is I can notice chloro. Where do I write this now? Okay, let me write it here. I can notice chloro. Another substituent I can notice is methyl. Then another substituent I can notice is this one here, which is ethyl, because it is 2 carbon. So I'm going to call that ethyl. You see, these are 3 substituents, okay? And I'm going to number them. Now, in this case, since there are more than one, we need to be sure which number we are taking. If I count from here, from left to right, it's going to be number 1, 2, this is 2, this is 3. Let me use a red pen. Okay, so this is 4, this is 5, and this is 6. So that means chloro is position 2, methyl is in position 4, and ethyl is also in position 4. Okay, let me use another color to represent the other one. Maybe a yellow. Let me use, okay, a brown. Yeah. So if I count this way, 1 2 3 4 5 6. Now counting this way, you'll notice that chloro is position 5, methyl is position 3, and ethyl is also position 3. So if I number these two together, you see that let's count it. 2 plus 4 plus 4. 2 plus 4 is 6. 2 plus 4 is 6. 6 plus 4 is 10. So this is 10. This numbering is 10. While this 5 plus 3 is 8. 8 plus 3 is 11. So we are going to go with 10 because 10 shows us the lowest possible number. You can see that's how it works. So once you count them, sum it up, then the lowest one is the one we are going to take. So that means we are going to take chloro in position 2, methyl in position 4, ethyl in position 4. So now we are going to write the name, but in writing the name, it must be in alphabetical order. Please note this. When you have more than one substituent and you need to write the name, it must be in alphabetical order. So between C, M, and E, C comes first alphabetically, then E, then M. So the name of this compound is going to be 2-chloro. Then we have 4-ethyl. Then we have, it should be a dash. We have 4-ethyl, then we have 4-methyl. Then we have hexane, which is the parent name. So you name the substituent, then the parent name. I really do hope that this makes sense. Okay, so let's see. This one represents alkynes, naming of alkynes. So the same way you name alkenes is the same way you name alkynes, just that the name should end with YNE. Okay, so in this case here, we have we just have a straight chain 1 2 3 4, that's it. So that will be both 1 yne, because this triple bond is in position 1. You see that? So for this one here, if I should open it up, it's going to be CH3, C triple bond C, then CH has a branch which is CH3, and then you have CH3 here. So the longest chain is 1 2 3 4 5. So that means pent. In this case now it is 2 ein. 2 ein because this double triple bond is in position 2. 1 2. You see, I can't count 1 2 3. 3 is too bigger than 2, so I'll go with 2. So that means every other thing will follow this naming. So this is 1 2 3 4. So that is 4 methyl pent 2 ein. 4 methyl pent 2 ein. You see that? Okay, so this is where I am going to stop in this video. Make sure you continue in other videos to see how to name other classes of compounds. Thank you very much. Bye bye.